Donut time. So this is number 18, and it says that you're distributing 20 identical donuts. So no different flavors this time. They're all plain or all chocolate. And but there's five customers, 5 nights that are all different, and you can think of them as having distinct names or being uh, like distinct shelves on a bookcase. So we're distributing the 20 donuts, and then there's some extra rules. So the first one is that the only thing is that they each have to get at least one. And so that means that they're all going to be greater than or equal to 1. So the way to think about that is to start out by handing out those required amounts, those required donuts, and then figure out how much is left to distribute. So in this case, each of them get 1, so you hand out each one each, that's 5, and you get 20 minus 5 is 15 remaining. So I'm gonna use the 15 now, and then the answer is gonna be 15, and now it's down to just distributing them, those 15, any way you want among the 5 nights. That's like 5 bookshelves, so you have to use the plus that number minus 1. And that's the whole answer. There are no upper limits on this part. We'll do that in the next. Just the lower limits mean that you decrease the total by that much to begin with. And so that's 19, choose 4. And I'll let you do the calculator math on that one. Now it goes to the more interesting problem. So this one is where it gets a little bit tricky because you have to keep track of everything the whole way through. It's not anymore no new method or creativity required, but there is more bookkeeping required. Let's see. So it says all 5 greater than or equal to 1 still, but now these are Arthur less than or equal to 3. It said no more than 3. So it's not allowed to have 4 or any more. Gawain less than or equal to 4, and Lancelot less than or equal to 2. So we'll start out with the previous problem. We already worked that out. Since they're all greater than or equal to 1, we'll still have the 20 minus 5 equals 15. So we want to work with 15, since then we'll work with 15 all the way through. The other tricky part of the bookkeeping is that when, for instance, Arthur has to have less than or equal to 3, that's going to mean that since he already has 1, then we won't want to give him any more than 3 on top of that 1, or any more than 2 on top of that 1. So you can't have 3 on top of that 1. So just to keep track of that, you could draw a little picture of it, or you can say just a little note to keep track. So A, G, and L equal 1 to start out with. So they already have 1. Okay, now we can work it. Actually set it up to finish. Okay, so to save some space, I already did the work for the total number of ways. 19 choose 4. It's a good idea to think those through. Now that comes from the 15 plus 5 minus 1 choose 5 minus 1. And then now I need to subtract. So first I'll subtract once for each of those 3. And then since there's 3 rules here, I'll have to add back in 3 choose 2, or 3 double rule breakers. And then finally I'll be subtracting the triple rule breaker. So the first one to subtract would be where Arthur is greater than or equal to 4. So that would be breaking that rule. It's allowed to have 3, but greater than or equal to 4 is bad. But notice, already has 1. So he already has 1. That means that greater than or equal to 4 would mean adding on 3 to that 1. So since A was already 1, adding 3 is what would break that rule. Okay, so that's what you do. You add 3 more to A, and then that means you can distribute the rest of them any way you want. Remember, this is finding all the ways that break the rule A less than or equal to 3. So if I add 3 to A, that means I'll have, I had 15 to start with, so now I'll have just 12 left to distribute. And there's still 5 minus 1 types. So I am going a little faster here. Like, instead of writing 5 minus 1 every single time, I know that's going to stay the same. It's always going to be plus 4, choose 4. But be careful that you don't look back at this number, since that one was already 15 plus 4. That 19 was 15 plus 4. So I needed to look at the 15 and say that's 12 plus 4. All right. So then for G greater than or equal to 5, G already has 1, so that's going to be adding 4 to G. That'll make G be equal to 5, and then I can add more to continue breaking the rule. But if I start out by adding 4 to G, there was 15, so that would be 11. And then finally, same for L. So for L, greater than or equal to 3, that'll break the rule. L is allowed to have 2, but if it's equal to 3 or bigger, no, that breaks the rule. So L already has 1, so to get to 3, you have to add 2 more. Add 2 to L. And then that will be 15. So if I add 2 more to L, I'll be left with 13. So I've got 13 plus 4, choose 4. Now it's time to add back in the double rule breakers. Okay. So having done this part carefully, I can look back at those, because now when I break the rule twice, 2 of the rules, then it'll be doing the same thing. So for instance, if I break rule A and G, I want to add 3 to A, and I'll want to add 4 to G at the same time. So let's see. I think I can erase that bit there, because I did write it over there already. Although maybe I should put it up here. In case you're looking back at the end, A, G, and L did start with 1. They all started with 1. There's 2 other knights that we're not naming here. We can look up some knights in the round table. They all started with 1, but the reason I wrote down A, G, and L starting with 1 is because those are the ones that have an upper limit, so I needed to remember that for them. I took care of the fact that they all start with 1 by dropping it to 15 already. So then this would be, the next one would be A greater than or equal to 4 and G greater than or equal to 5. So both of those, true, mean that I need to add 3 plus 4 to their pile. I need to add 3 to A, and I need to add 4 to G, so I'm going to need to add 7 total to their pile, to their bag of donuts. And that means that I need to subtract 7 from 15 to see how many donuts I have left to distribute. So 15 minus 7 is 8, plus 4, choose 4. A little hard to read there. But you have the answer too. That shows you where it came from. Then the next two, I do A and G, so A and L. It's all the different choices of 2 there. So A greater than or equal to 4, L greater than or equal to 3. But look at what I needed to add. I needed to add 3 to A and 2 to L in order to get there. And so I'll need to add 5. Add 5 donuts to their piles, which means that I'll be left with 10 donuts to distribute. Then finally, G and L. So G greater than or equal to 5, and L greater than or equal to 3. Means they add 6 donuts to their piles, or books to their shelves. And from 15, that means I would have 9 left to distribute. Now I ran out of space. There's one more step because I need to subtract the last term. That's where you break all 3 rules at once. I did 1 rule at a time, then I added back in 2 rules at a time, but there were 3 rules this time, so I need to subtract all 3 rules at once. So let's see where I can fit that. Right down here perhaps would fit. So I need a minus, and this is going to be all 3, so I should just be able to look at all 3. We're going to add 3 to A, 4 to G, and 2 to L. So that's a total of 9 donuts that I get to add to their piles before I start distributing. And 15 minus 9 is 6. So make sure you don't forget that last step. I'll put an arrow to it. All 3 rules broken. And that explains where I got the numbers in the answer. And again, I'll leave the calculator work for you. Mostly need to get those combinations correct to begin with.